We're now going to use a technique for solving quadratic equations by a method called complete the square. And the reason for that is we want to eventually use the square root method. So with the square root method, when we have something squared is, I'll say box squared is triangle. Once we have a quantity squared, then it's easy. We just take the square root of both sides, and we get like boxes plus or minus square root of triangle, and basically from there we'll be able to solve for x. What's going to happen is that we're going to be given equations that are quadratic that aren't in the parentheses squared form. So for example, I might say solve for x squared plus 4x equals 7. This is not as a parentheses square, and complete the square is a technique where we can write this as a parentheses squared. Before we can do this, let's look at x squared plus 4x. This is going to be something squared, so it's going to be x times x, and we're thinking about what number can we put in here that when we double it in the middle, it gives us the 4. So we're thinking x plus what? Because you're going to have two, inner and outer, two of those that are going to give you the 4x. So doubling that to give 4x, to figure out that number, we're going to take half of 4. And half of 4 is 2. So we put in 2. Now it turns out when we FOIL this, we'll get the x squared. We get 2x and 2x. We get the 4x. And now we see this last path, 2 times 2 is plus 4. That's what's missing to make this look like a perfect square. Once we put that in, then this can be written as x plus 2 squared. It occurred twice. So in looking at this, we see we can almost get it as a perfect square if we add 4. But to add 4 to one side, we have to add 4 to the other so that we don't change the equation. You have to always add to both sides. This now becomes x plus half of the 4, as we saw here, is 2, and that then gave us that 4, is now equal to 7 and 4 is 11. We now have the perfect setup to do the square root method. Square root method, we take square root of both sides. Square root of square gives us x plus 2 is plus or minus radical 11. We're almost finished. We just subtract 2 from both sides, and we get the two answers, negative 2 plus or minus radical 11. So the original equation, now we were able to write it as a binomial squared and then do the square root method. We'll work through another one. So for example, suppose I said solve for x squared minus 10x equals 12. We're going to have to complete the square on the x squared minus 10x. So we have x squared minus 10x, and we're going to have to add something. And that's going to be something times itself, or something squared. So we know right away we have x and x. I now have an inner and an outer, and it has to give me negative 10. So I have the half of negative 10, because I'm going to have two of them, negative 5, negative 5. That gives me my negative 10x. And now the last term, negative 5 times negative 5, will give me plus 25. So I have to add 25, and then this can be written as x minus 5, that quantity squared. This equation, I'm now going to complete the square. I add half of negative 10, negative 5 squared, 25 to both sides. That accomplishes what I want. This can be written as quantity x minus 5 squared, and 12 and 25 is 37. Now I'm ready for the square root method. So the square root of both sides, Square root of square just undoes it, and I have x minus 5 is plus or minus radical 37. Now I just add 5 to both sides, and I've got the two solutions. 5 plus or minus radical 37. We'll do another one. Notice here the negative 10x and the 4x, those were even numbers, so it worked out nicely. But for example, suppose I ask you to solve for x squared plus 3x equals 8. Now on the side I have my x squared plus 3x, and I'm going to add something, and this is going to be x plus something squared. The technique was to take half of the middle coefficient. So if I take half of 3, that is 3 halves. So I'm going to put 3 halves. Now what I'm going to add, I get that by doing x plus 3 halves, x plus 3 halves. We see I get the x squared. I get 3 halves and 3 halves, double that is 3x. And now we're going to do 3 halves times 3 halves. So 3 halves times 3 halves, 3 times 3, 9, 2 times 2, 4. I am going to add 9 over 4. So that's what I add to both sides. And I'm going to put 8 as a 1. The whole purpose was to write this as something squared, which we just saw. X plus 3 halves squared. We just did that all over here. And now I'm going to write this as a fraction. I have a nice trick for that. I call it the rocking chair. 8 times 4, 32, plus 9, 41 over 4. We now have that the quantity squared is 41 over 4. I'm now ready to do the square root method. The square root of both sides. This undoes the square. We have x plus 3 halves is plus or minus the square root of 41. I'm going to write it separately, numerator and denominator. Square root of 41 over square root of 4, which we know is 2. Now we just subtract 3 halves, and we get x is negative 3 halves plus or minus radical 41 over 2. But we're supposed to notice that both of these have the same denominator, so the answer actually gets written like this. Negative 3 plus or minus radical 41, both of them over 2. We're now going to go to the next page. We're going to do one where there's not 1x squared, but a number x squared other than 1. We're going to do this solve for x, this quadratic. First thing that we'll notice in this is that we have more than 1x squared. We have 2x squared, and we don't have the number on the other side. So first step is we're going to add 3 to both sides. That gives us 2x squared minus 12x is 3. We don't want to complete the square with 2x squared. We know how to do it with 1x squared. So we are going to divide both sides of the equation by 2. And 2 by 2 here gives us x squared. Negative 12 over 2 minus 6x equals 3 halves. We are now ready to complete the square. At this point on the side here, we're completing the square, x squared minus 6x. What are we going to equal so that it's x minus something squared? And going through, we know half of negative 6 is negative 3. And sure enough, when we do the last term, negative 3 times negative 3, that's going to put plus 9. So we're going to put plus 9 to both sides. The whole purpose of doing that was to write this as the quantity x minus 3 squared. And now I put a 1 here. We're going to write this as one fraction. So it's 3 plus 9 times 2, 18. So it's 3 plus 18 which is 21 over 2. Now, the minute we have a parentheses square, we're ready for the square root. And now we're taking the square root of both sides. Square root squared will undo itself. That gives us x minus 3 is plus or minus radical 21 over radical 2. But we cannot have a radical in the denominator, so we're going to have to rationalize that before we finish. We're going to multiply top and bottom by radical 2. We get x minus 3 is plus or minus radical 42 over radical 2 times radical is just 2. Now we just add the 3 to both sides. We get x is 3 plus or minus radical 42 over 2. And that's fine as one possible answer. Sometimes we want to write the 3 as 6 over 2. Another way would be to write it 6 halves, and that would be 6 plus or minus radical 42, the whole thing over 2. And those would be our two solutions.